Good morning all. Welcome to next lecture. In the last lecture, we discussed and differentiated the concept of relation and function. And we defined a function is a special kind of relation, or it is a well-behaved relation in which there is only one output for each given input. A relation from set A to set B is said to be a function. See, if every element of set A has one and only one image in set B, that means, see, every x value must be associated to only one y value. Mathematically, we can write f is the function from A to B. Here, A is the domain and B is the codomain. So, we are already said that, see, all the functions are relation, but not all the relation are function, because we know a function is a special kind of relation where each element in the domain is associated with exactly one element in the codomain, which means there are no repetition of the input and each input has a unique output. A relation is more general concept, but at the same time, function is not. It is, something specific kind of a relation. Why it is so? It can be any set of ordered pair. A relation can be any set of ordered pair, and it may or may not be possess the property that every element in the domain is associated with unique element in the codomain. That's why we are saying all the function are relation, but at the same time all the relation are not a function. Now we are going to discuss different types of function which are classified based on different criteria like number of variables, nature of relation and degree of variables. See, the first one is into function. Into function. See, if a function from A to B, if f is the function from A to B is such a that, mapping such a that at least one of the element in B is not an image of any element of set A. That means if there exists at least one of the element in the codomain, at least one of the element in the codomain which is not an image of any element in the domain, then the function will be generally known as it is into function, and it is also called non-surjective function. It is also called non-surjective function. Consider one mapping diagram so that it will be more clear. See here, every element of the domain are related to the first four elements of the range. A is paired with 1, B is paired with 2, C with 3, D with 4. So, the first four elements in the range which is already paired. Accordingly, we can say that this relation is a function, no doubt. However, see here, the fifth element in the codomain, that is, see, this 5, which is not paired with any element of the domain. So, if this is the case, we can say that there exists an element in the codomain that is not mapped to any element in the domain. So, this function is called an into function. So, into function where mapping such a that at least one of the element in the codomain, that is B, is not an image of any element of the set A, then such a type of function is known as it is into function. Now, the second type of function, it is known as OntoFunction. See, if f is the function from A to B, a mapping such a that each element of the B has an image of at least one element of set A. If for every element of B, there is at least one or more than one element matching with pre-image, then the function is said to be a OntoFunction. See, it is also called a surjective function. In this case, generally what happen? Your range is equal to codomain. The range will exactly equal to the codomain. For example, we have a mapping such that every element of the range is paired with any element of the domain. See, none of the elements in the range are left unpaired with the domain as like the earlier cases. So here, every element in the codomain has at least one arrow. So here we can have a one arrow point to it from the domain. So in the case of an OntoFunction, the range is equal to the codomain, and it means that every element in the codomain is covered or reached by a function, and no element in the codomain are left unmapped. Consider another type of function which is known as one-to-one function. See here, if all the distinct element of domain has a distinct or unique image in the range, then the function is said to be a one-to-one function, or it is also known as an injective function. This one-to-one function is also known as an injective function, and it is the type of function in which distinct element in the domain map with distinct element in the codomain, which means not two different elements in the domain produce the same output. Here see, all the elements in the domain and range are paired each other in such a way that all the distinct elements of the domain, that is A, B, C, D, has a distinct or unique image in the range, that is 1, 2, 3, 4. It is one-to-one mapping. So this is an example of a one-to-one mapping. Now we have little bit confused because of OntoFunction and OneToFunction. It look like a similar in mapping. However, in both functions, see what happened. There is a little bit differences. See, in the case of OntoFunction, which focus on covering the entire codomain by ensuring that every element in the codomain has at least one pre-image in the domain. So that's why the range is equal to the codomain in the case of OntoFunction. So it is the relation which is starting from codomain to domain. Every element of the codomain have a element in the domain. So however, in the case of a one-to-one function, which is also known as an injective function, which focus on all the distinctness of elements in the domain by ensuring that no two different elements in the domain map to the same element in the codomain. See, that's why the range might smaller than the codomain in the case of a one-to-one function, and not all the elements in the codomain need to be covered. But in the case of one-to-one, entire codomain will have every element of the codomain has an at least one pre-image in the domain. So that is the basic difference between OntoFunction and one-to-one function. Now we have another type of function which is known as many-to-one function. See, if two or more than two elements of a domain have same image in the codomain, then such a mapping is said to be a many-to-one mapping. See, in this mapping, see here the mapping is given, the domain and range is given here. A, B, C, D are the elements of domain, 1, 3 are the elements of range. See, in this mapping, A and B, see the domain share, the A and B share the common element 1 in the range, while C and D, which share a common element of 3 from the range. See, while we discussing many-to-one function, you may think over there is another type of function, that is one-to-many. This is many-to-one. So of course there may be just opposite of it, that is one-to-many. See, one-to-many can occur, but it is a relation, it is not a function. Why? See, because as per the definition of function, they are not the function, because it will not be a well-behaved relation as there occur common domain for different range. If a single input element in the domain is associated with more than one output element in the codomain, it violates a unique requirement of a function. So one to many can occur. It will be a function, no doubt, but at the same time, one to many is not a function. Now, consider a mapping given here. See, mapping A1, B2, C3. See, it is a mapping given here and we want to check whether it is a function or not. And if it is function, see, we want to identify which type of function it is. See, this mapping shows that all distinct elements of a domain have a unique image in the range. No doubt, we can say that in that particular sense, it is a one-to-one function because all distinct elements of a domain have a unique image in the set B or range. So therefore, we can say that it is a one-to-one. It is a one-to-one function. But at the same time, see, one of the element in the codomain, that is 4, it is not an image of any element of the domain, which means that element 4 in the range is left unpaired. If it is so, which type of function it is? It can be a into function. It can be a into function. So here the both properties, that is the property of one-to-one function and the properties of into function, both are exist here. So this function is generally known as it is one-to-one into function. It is one-to-one into function. Now consider the another mapping diagram. See, domain and codomain is given here. A, B, C are the elements in the domain. 1, 2, 3 are the elements in the range. See here, all the distinct elements of a domain have a unique image in the range. No doubt, A with 1, B with 2, C with 3. So therefore, it can be, say, it is a one-to-one function. Of course, it is not a doubt. None of the range is left unpaired. Any one of the element in the range is unpaired with the domain. Therefore, we can say that it is a onto function. It is also an example of an onto function. So since we have both characteristics of a one-to-one function and onto function, see, this function is known as a one-to-one onto function. It is a one-to-one onto function. Now consider another mapping. See, mapping here, domain and range is given here. The elements of domain are A, B, C and the elements of range are 1 and 2. See what type of mapping it is. See here, two elements in the domain, that is A and B, share a common element in the range, that is 1. So in this case, we can say that which type of function it is? It is a many-to-one function. It is a many-to-one function. And at the same time, see, none of the element in the range is left unpaired. All the elements have a pair in the domain. So none of the element in the range is left unpaired with the domain. So we can say that it is an example of an onto function as well. Since we have the properties of one-to-one function and onto function, see, this type of functions are generally known as it is many-to-one onto function. It is many-to-one onto function. So this is an example of a many-to-one onto function. Now we have another mapping. Here domain and range is given here. A, B, C are the elements in the domain and 1, 2, 3 are the elements in the range. See, two elements in the domain, that is A and B, share a common element in the range, that is 1. So it is a many-to-one function. It is one of the example of a many-to-one function because C is also having the pair in the range. It is an example of a many-to-one function. And at the same time, one of the element in the range is left unpaired, that is 2, which is left unpaired with any element in the domain. So accordingly, it is an example of an into function. It is an example of an into function. Since we have both characteristics of many-to-one function and into function, See, this type of function is known as many to one into function. Many to one into function. Now there is another type of function which is known as identity function. See, it is a specific type of function where the output is equal to the input for the every element in the domain. Every element in the domain, see, we have output is equal to the input for every element. It means that a identity function maps such that each element to itself. That means it has a same domain and range. Because in this particular case, each element we are pairing with itself. So therefore, it has same domain and range. And it is also known as identity mapping or identity relation. And the identity function can be mathematically written as, for example, f of x is equal to x. Or we can also say that it is y is equal to x. We can write this function, that is f is the function from a to b. F is the function from a to a. It is the function from a to a. See, we have a mapping diagram which is given here. The set A and set B, domain and codomain is given here. We have elements here 1, 2, 3, 4 and here also 1, 2, 3, 4. See in the mapping, for each case, that is 1 to 1, 2 to 2, 3 to 3, 4 to 4. Each case the output of a function is exactly equal to the input. If you go for graphing of this type of identity function, it will look like a straight line. If you go for mapping or graphing, the particular graph of this particular function, then it will be straight line that pass through origin, this particular point, with its slope is generally considered as a 1. Because at this particular point it is 0, 0. See, at this particular point it is 1, 1. That is value of x is equal to 1, value of y is equal to 1. At this particular point value of 2 is equal to 2, value of y is equal to 2. So it will be look like a straight line that pass through the origin. Its slope is generally considered is equal to 1. And this line is actually represent where all the points, that is x and y, where x coordinate and we have y coordinate, and both x and y coordinates are equal. So this is a special type of a function, that is identity function. Now we have another type of function which is known as constant function. See, a function is defined by a single constant value. If it is defined by single constant value, or a function whose ranges consist of only one element, is called, it is a constant function. For example, f of x is equal to 2. See, a constant function is a special kind of polynomial function, that is a polynomial function of a degree 0, which is called a constant function. And it means that the value of function is always same, regardless of the input value of x. See, mathematically, we can express f of x is equal to c, where c is nothing but it is a constant value. For example, see, if y is equal to 2, f of x is equal to 2, that is, for example, y is equal to 2. It is a constant function. And here, whatever be the value of x, the y value will be same. That means y value is not going to change. It will remain 2 for different value of x. So that is the output or dependent value is always the same regardless what is the input value or what is the independent value, as it will remain constant throughout this particular function. And if you go for graphing, see here, for example, if it is x is assuming minus 2, then also it is 2. If x is assuming 0, it is also equal to 2. If x is approaching to 2, then again f of x is equal to 2. And the graph, it will be look like this. See, a graph of constant function is a horizontal straight line parallel to x-axis. Whether value of x is equal to minus 5, minus 4, minus 3, minus 2 or 0, 1, 2, 3, 4, 5, see the value of y is remain constant, which is equal to 2. So this is also a special kind of function which is known as constant function. Now we have another type of function which is known as one independent variable, a function of one independent variable. See, if the dependent variable depends on single independent variable, then this type of relation is known as a function with one independent variable. For example, see, if x and y are the two variables such that x is an independent variable and y depends upon the variable x, then we can say that y is a function of x. Y is a function of x. We have only one independent variable. Y is the dependent variable and x is the independent variable. And here we have only one independent variable. See, in this particular example, the dependent variable y is depending upon only one independent variable x. So the relationship between dependent and independent variable is generally visualized by using, coordinate system. And the graph of the function of one independent variable is typically a curve or set of points in the Cartesian plane, and the shape of the curve entirely depending upon the power of exponent. For example, see here y is equal to 4x square plus 5x minus 2. This is a function of one independent variable. See, the independent variable here, it is only x, and y is the dependent variable. So in this particular case, we have a function with one independent variable. Now we have another type of function which is known as function of two or more independent variables. See, in this case, if the dependent variable is influenced by two or more independent variables, if the dependent variable is influenced by two or more independent, that means more than one independent variable we have, then we can say that the function is known as function with two or more independent variable. See, for example, if we have x, y, z are the three variable, x and y are two independent variable, and z is the dependent variable, and z is depending upon y, x and y. See, we can write it is z is a function of x and y. Here x and y are the independent variable and z is the dependent variable. Here the dependent variable z is the function of more than one. That means two or more than two independent variable we have, that is x and y. For example, see, if z is equal to 4x square plus 5y square minus 2xy. See here, the z is the dependent variable, x and y, we have two independent variable here. So we can say that it is a function of more than two independent variable. See here, the variable z is depending upon two independent variable, that is x and y. This can be any number of independent variable in this type of function. It may be more than 2, 3, x, y, maybe a, b, c, just like that. We have more than two independent variables. Then also the relationship can be represented. If we have two independent variables, then the relationship can be represented by using three-dimensional space. It is generally, if you are graphically represent this particular function, that is function with more than two independent variable, then this will be just look like a three-dimensional space, and the graph may be a particular surface rather than a particular curve. So let me conclude here. In this lecture here, we discussed the different types of function like OntoFunction, OntoFunction, one-to-one function, many-to-one function, identity function, constant function, and finally we are also discussed the function with one independent variable and then function of two or more independent variables. There are many more functions are there, which we will discuss in the next lecture, and then we will see in the next lecture. Thank you.